Hello, hello, hello. Ready to take on Admin of Code Day 7. 40 seconds away. Got my VS Code ready to go. A little bit of housekeeping. The Day 6 Part 2. I still have yet to actually complete it. With some fresh eyes and fresh brain, I have an idea of what might make it do better and what was wrong with it in the first place, but I will save that until I get to it, which will hopefully be after this, or it'll be tomorrow night. I'll just be able to start a little earlier and clean that up then. But here we go, day 7. Let's do this. We got a bunch of rows of things we need to do some parsing on. I love it. Dot trim. Get these. We love it. We're going to do stuff with them. This is this number, so we're going to do numbers. We love numbers. Is this a thing and then we add them all together? The sum of the test values. There we go. Okay. Let's sum 0, const align of data, split, new line, dot. Yeah, so for every line we have const left right equals line dot split colon, and then, well, it's colon space technically. So what is this? What is this? What is this? Only three. The equation. The remaining numbers. Blah 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 blah. What's 190 mean? Okay, so const target equals plus left const nums equals right split on the space map to numbers. Now what I'm supposed to do here, evaluated left to right, not according to precedence. Numbers cannot be rearranged. Glancing, add and multiply. Okay, so this is just permutations of, hey, you have these things, use all the operators you can try to get it to do the thing you want. So it's permutations, or it's being smart, but I'm gonna go permutations. My brain for permutations. So const attempts and const things equals constant completes equals num. Well, num's 0. So the idea here is that I got a bunch of incomplete things. I'm going to keep trying it until I build a full thing, and I'm going to send it off. So while false, so we're going to return here completes.length const expression equals incompletes.pop. And then what we want to do is add a random operator and add a random number. Okay, so this is gonna be kind of hard to do. What we want is we want a list of numbers and then a list of operators, which is -1. So it's basically operators. While if okay, so what we'll do, we'll call this ops, and if no, we'll do that up there. So ops dot go for const op of plus asterisk ops, well, const new ops equals ops dot, it's a new ops, and then you add the new operator. Congratulations, if new ops dot length equals nums dot length -1, because there are two things and you need one operator. Congratulations, then try it. Else incomplete stop push new ops. Let's get types going in here. This is a string array. Congratulations, ops. Don't worry, it's not undefined. We're good. If it's this, then we're going to do evaluate. So const result equals nums dot map num I, and then I guess it's num plus ops I. Eventually that'll become undefined, so I kind of want a flat map. So I want to make sure I can properly make this thing first, I guess. This, that, that filter things that are not empty. So v not equal undefined. Let's just see const expression, and then we'll look into evaluating that. So I've written a lot of stuff. Let's see if we can do that. Move the return down to here. Let's see expression 1019. It ain't doing the thing. I want new ops, not old ops. Okay, we have both operators. Boom, we have it. What's the cheeky thing that I can do in Node? What is that? Except eval. Okay, I remember my languages. So result equals eval expression. Nope, not exp. Expression dot join spaces if result equals target. What am I supposed to do for this? Because some of the test values that could possibly be true, so it's the ones that can be true, right? What's one? Only 3 can be made true. Okay, trueable. Then break. We found you. Possible equals false. Let. And here we set possible equals true. Congratulations. If possible, sum plus equal target. Return sum. 34 not equal to 37. Okay, so more of them are possible than that should be, so I need to look at which ones are being said to be possible, which should not be possible. So target nums. So only these two apparently. For example, each represents operators. So this one is doable, this one is doable, this one is also doable. But it's saying it's not. Okay, so we just need to see what the expression is. I need to look at all the expressions. If target equals, what am I looking for? 292. Okay, let's see all the expressions you came up with. So you did the plus, you did the, yeah, you did all variations, it looks like. Plus times plus. So plus times plus. I mean, what result did you get? If target is 292, console log expression, eventually you should get 292. Ooh, that's right. It's being evaluated not using, what is it? Pendes or whatever. It's not using the order of operations. They're just raw left to right. But eval does the order of operations. We don't want that. So what do? I just start stacking parentheses? Like, how do I make this turn into 292? Is it just, we be stacking? Yeah, I think so. Stacking parentheses would suffice. Yeah, so what we can do is filter new ops I. New ops I. And then just like closing parentheses. So this isn't gonna work initially, but let's look into expression, and then I just add as many as I need to the left. So it's, ooh, that's the wrong place you would do in that. We need it here. Not there. This is all also the wrong place. I could just do this manually and do it one by one. Manually express every three numbers till there are no three left. I'd rather not do that. I'd rather just start throwing parentheses everywhere. But this is getting a little tougher. So let's make a tiny little function. Function. Name the thing. String or number array. And then it's while expression length not equal 1. Const left equals expression, well, const things equals expression dot slice 0 3. Const result equals eval things dot join space expression splice 0 0 result turn expression 0. That should do it. So let's see, instead of doing this, we say const result equals ta-da. Drop the old one, drop that. Unexpected number. Why are we doing this? Did I not capture them all? If I capture them all, ooh, am I inserting? Oh, I'm not pulling them out. Splice. There we go. Now we can't read from a split. That's because we have the right answer and we are failing for no input. Give me my input. Don't kill my computer. Please don't kill my computer. Ooh, that is a lot of expressions. So if we were to see 07, 07 pxt, oh, we ran. Okay, so it's not as big as I thought it'd be, but is it correct though? It is. Now I probably need to make these invalid ones correct in some way, right? Combines the digits from its left and right into a single number. Ooh, a special operator. Okay, so I just try up another operator. A lot more possibilities thanks to this. It's gonna be a little painful, but we will do. Yeah, let's just spin up another version of this. Solve 1, solve 2. My little function will need to support additional operators now. So this needs to be an array of strings. If anything, this shouldn't be an array of functions because it's special calls. But we'll keep them as strings. We'll do the processing up there. Let me get my solve 2 example. Oh, the above example has more examples. Okay, so use the previous one. I got it. Come on, give me input. And whole function parentheses. Oh, geez, it's a lot of indentation. Okay, the number goes up to this. That's a really high value, but okay. So, yeah, we're not doing that because we're not doing anything yet because I have this one defined down there. Let's move it. Okay, I think it's really the eval raw expression that just needs to go and do more. Evals join. So how does that look? 1.5, it's literally just smushing them together. Okay, so if things 1 equals da da, you're a weird operator. Then let's put the else here. Let's say let result equals 0. Boop 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 boop. Otherwise, result equals things 0 to string plus things. Where's my plus at? things to string. Congratulations, you smushed all the digits together. Now you're gonna make them a number. Boom, it's doing the thing. Is it working for part two? It is, and it's running on the actual code. Now, I forget how long it took the initial to do this, so I'm gonna go spin my terminal up and target it while it does eat my computer alive. Cannot repackage JSON. Excuse you. Oh, that's forgot that bit there. Okay, so that's running. It's gonna keep running. I'm gonna turn this off while I think of more efficient ways to do this. Because that's either gonna work or it's gonna take him 500 million years to work. I'm expecting this to take longer, unfortunately. Um, so, just trying everything. Obviously, not the move. It's much similar to yesterday's part two. Tackling a challenge of efficiencies. Well, yesterday's part two was missing actual things. So I'm doing a lot of expensive operations here. We can target that, or we can go for thinking of actual better way to do this, a better algorithm. Okay, that's gonna take longer than I'm hoping for. Okay, so we go through each one. Now this is depth, so we are trying to get the first one buildable. That is what we want memory-wise. I was really hoping that thing would finish. This is kind of a gross way to build up the expression, but this only happens at the end, so honestly, this is fine. If there was some heuristic or something that I can figure out that's like, hey, I know what I need to do to get close to it. Hmm. Is it still left to right? Okay, it's still left to right. That's good. We could do a thing where we kind of sort them in the order of, hey, you've built an expression and here's how close you are. We also can optimize by doing some of the evaluation inline. So instead of just building up this thing, we can just build it up to a thing. So instead of just collecting a bunch of operators, have the things, insert the operators, consume it until you have none left. Let's try and target that. I don't think it's going to be the solve, but it's going to be more efficient, I believe, because you're reducing the evaluations to just once, literally. So we have incompletes, which is, well, it's string and an array number. Well, it's a string and a number array, is what I meant to say. And we'll start with, I guess it's nums. I'm trying to envision what this, I want this to be. Yeah, go ahead and, you're not gonna go nowhere just yet. That's a number. I'ma take it. Took an infinity to calculate, but we got it. Woo! Okay, it's good enough. Hey, refresh the page. Okay, we did it. Okay, wait for that. I am not making that change. I'll commit it as is. I'm going to stop Quokka. Commit it as is, and then we will break it down and make it some refactoring attempts, and then walk through that new code. So it's log add 07 solution. Boom, loving it. Okay, we have that. So, what the heck do they want from us? So they gave us a bunch of expressions, kind of. Yeah, they gave us pseudo expressions. They're not mathematical expressions. They gave us a list of lines, each line being a subproblem. You're supposed to add up all of the problems that successfully are solvable, they're target values. So if 190 and 83 are the only problems that are solvable, you return, well, the result of 190 plus 83. Now, what determines a solvable subproblem? Well, you're given a target and then a space delimited list of numbers. You are supposed to use the plus and multiplication operators. Those are your possible options, and put them between the numbers, attempting to generate an expression that you can evaluate to get the result here. So if you did 10 plus 19, you get 29. 29 is not equal to 190. So using the plus operator does not get us what we need. Using the multiplication operator, though, 10 times 19, 190. Boom. Now, which one you use and don't use doesn't matter. What matters is there is a way, at least one way, to use your operators, pluses and multiplications, to make this list of numbers turn to an expression that evaluates to this. Once you find one, boom, you solved it. This is a solvable line. Move on. The other trick is that you're not using order of operations. So no PEMDAS, no other sayings for it. So when you see the multiplication operator right here, math would tell us, oh, we need to do this multiplication, then do this addition with the result of the multiplication, then do this final addition with the result of the addition to the multiplication. No. It's 11 plus 6, so that's 17 times 16, the result of that plus 20. It's literally left to right. Those are the only two tricks, or the only two notable things about part one. Part two is you get a new fancy operator that is these two vertical pipes that aren't a real operator, but it's one we're using in this universe. And when it's used on its operands, it takes the digits and it smooshes them together. So 12 concatenate 345 equals 12,345. Fancy new operator. You just use it. It goes into your pool of available operators. So plus, multiply, and concatenate. Try and mix and match them to make your list of numbers evaluate to your target number. Relatively straightforward, thankfully. It's just the doing of it is where it gets a little gnarly as we saw with my performance. Speaking of, let's go through this code. So, what we do is we go through every line. I'm going to drop these so we can get Quokka turned back on without eating my computer alive. So we go through every line, we get what's in the left, what's on the right. We turn the left into a number using the unary plus operator. We turn what's on the right of the colon into an array of numbers. So we have targets and nums. As you can see, 190, 10, 19, all parsed out. Excuse me, as expectedly. And then this is where we get a little inefficient in the process. Now, what I've done is effectively a recursive process. I didn't physically use recursion, I just stuck it on the stack into this here array, but it's a recursive process where you are building an array of operators. And you are building that array of operators to be the length of your numbers minus 1. So I'm going to return right here so we can see what's going on. Now, it's 10 and 19. Now, how many operators can we put between 10 and 19? 1. Right there. Now, if it were 81, 40, 27, how many potential operators could we put in there? 1, 2. There are 2 slots for operators. Now, permutations, you get 2 here, then it's 2 times 2, it's 4 here, and the more the merrier. 2 times 2 times 2. But we're just talking about how many slots there are. There are 2 slots for operators here, 3 slots here. So we build up an array of that many operators. So we get out our previous one, which is 0. We add both plus and minus to a new list, and we push that to incompletes, which is effectively our recursive stack call parameter of these are all the ones that we're just collecting a bunch of operators, every variant and every permutation, until we hit the length here. So I'm just going to go ahead and output new ops to show, well, for this one, we only get the 2. This is a horrible example. Let's skip this. There we go, 3. So for these 3 operators, there are, well, 3 ways of doing this. Multiplication plus, 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 plus multiplication. Technically, there's also multiplication, but we give up once we find the right one. If we don't give up, there you go. So this is now 2 by 2, all 4. So these are all the permutations of operators that are possible. We're seeing it now because we've reached the number of operators we're looking for, which is number of numbers minus 1. It's always a minus 1. That's the number of slots we have available. Once we have that, we generate the expression, which is basically just combining the numbers and their operators in a pattern like this. Now, there's probably a fancier, cooler way of doing this. I use flat map, which you can return an array from, and it will return it back into a single flattened array. But sometimes this new ops for the last one is undefined. So if I don't do this, you can see the last one, like 27 is trying to add its operator. There's no operator after 27, so we get undefined. We hate undefined, so we filter it out at this point. So we effectively generated 3 arrays, an array of 81 star, an array of 40 plus, and an array of 27. And then we flattened them. I can show you those array by calling it a direct map, and there are those 3 arrays that we generated. So we do that to generate an expression, and then we say, hey, let's evaluate this expression. Now we have part 2 code in here, but pretend that doesn't exist for part 1. What we do is until we have only 1 thing in the expression, we get 3 things out. Now, since it's a simplified expression, those 3 things are always going to be the left operand, the operator, and the right operand. So it's a sub-expression, I suppose you could call it. Well, once we have those, we join them together, we pass them to evaluate, and then we get our result. Then we take our result and we insert it back into the beginning of the array. So that way we replace, go look at this expression here. I think it'd be easier if I actually just showed it in place. But here it is. It's not red, it's white. Not very scary. So first we do, so just to show what the array looks like. First we get rid of it. So now we have plus and 27. Very sad. They're all alone. They should not be alone like this. Then we perform the result of 81 times 40. Tell me. 3240. So 3240 is now what that turns into. Then we pull out these 3. We do whatever the result of this expression is. 3267. And we put it back into the array. And at this point, that while conditional will be like, hey, there's only 1 thing in here. Let's give up. Let's stop the while loop and let's return whatever that 1 thing is. This allows us to just evaluate our expression one thing at a time, not in the order of. Well, it evaluates it left to right as they asked us to. If it is our target, then congratulations, we did it. We found what we were looking for. We can say that we found it, and we can break to effectively stop the recursion, stop the calls, stop the presses, and we're good. If it's not good, or, well, if it's not the length we need it, we push it to our stack of things to keep trying and adding to, and the process eventually ends up here and kills everything. Finally, if it is possible, this is just our final function of, hey, let's add you to the number we're going to be returning at the end of the party. The only and singular difference that part 2 has are these two lines. If you have, okay, there are 3 lines. Let's go for the first one. I lied. Here it is. We have a new operator that we iterate over. Okay, that's line 1. Line 2 is when we hit that new operator, since it's not a real one, we can't just chuck it to eval. We convert the left operand to a string, the right operand to a string. We smush those strings together, so put the digits together, and convert that back to a number and call that our result. That's it. Now I've broken something. Don't know how. Oh, slice 1. Yeah, I was skipping. Let's not do that. Okay, and that is our solution walkthrough. That's how this code works. Now, it ain't pretty, but it does its job. And there is opportunity for a great refactoring. We'll start with just cleaning it up as is, honestly, and then we'll go for a real refactor. I do believe I have something to do that will make it better. Hey, good morning / good night, Rask. Hope it's going well. You made a good attempt on it. Just going for the refactor myself. So let me see. Eval raw expression. I like this. Yeah, first I'm just gonna generalize it into one function, as always. I kind of brute forced it, Rask. I kind of just went for the, hey, let's generate every possible operator variant, evaluate all of them, and see if we hit the target. Yeah, of course, yeah. Yeah. I have an idea for an optimization that's just brute forcing but more efficient. But I don't know, I haven't thought of the good algorithm for this particular one yet. Not too concerned with it. Uh, doesn't feel that custom. I mean, it's really a glorified permutation generator. And then once I've generated, the permutation is fully generated, I evaluate it as an expression. Like with shorter branches, if not percent value equals 0 or value is greater than 0. Hmm. Maybe. I could see. Like, I definitely know there is an optimal way of doing this. Hadn't thought of that for sure. Tree from left to right, divide or subtract the root. Hmm. Oh, right. Work from the root backwards. Hmm. I could see that. Yeah, I didn't even literally conceptualize using the target as something to help me solve it. Yeah, there definitely is a heuristic. It's not divisible, yet not valid. Stop there. Nice. Yeah, that would definitely do for part one. This weird part two one, I think, would explode that idea, but yeah, I think that would work for part one. Yeah. Hmm. Yeah, interesting. Yeah, I'd be curious to see how that turns out. Yeah, I think for me though, I'm just gonna go with the cleanup and go with some early evaluations and try maybe a heuristic of prioritizing the calls to which ones get closest to it. So just a better brute, honestly. That is a thought. See what you're thinking there. So, this technically works. Yeah, first I just want to generalize this as I have it. Do 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 do. Because the literal difference between them both is you got a new operator. Operators. String array. Love it. Or op of operators. Boom. Solve data and plus multiply. And then we just add our fancy concatenate friend. Oops. And they are generalized. Now, if anything, I am fine with this at the moment. I'll get bored of it in a second. Let me break out the detection for is possible into its own function. Function can be, what do they use for this in the story? Calibration result. Give me the lore. Trying to repair it. Operation is evaluated. Equation can be made true. So that's a good enough. True. Target number numbers number. What do they call these? Test value appears. Determine the remaining numbers can be combined. Okay, test value. I don't like that name. I like target instead. Let's take this and shove it in here. We have to still have our operators. That's not where that parameter goes. Yikes. There we go. Better. Whoops. Now let's go ahead and rename them all. Numbers. We love it. Now instead of setting a flag and breaking, we can straight up return. Love making that cleaner. Now we can use our cool function. If can be made true, target numbers, operators. A, of course, Rask, yeah. Go ahead and enjoy your sleep. Yeah, it's, not one of the. It was a long Friday for me, too. So I hope it was worth it. Thanks for coming on by. Okay, let's start shoving these into here. Oops, I needed that one out there. Yeah, let's not put them in there. Target numbers. Great. That's good enough. Now let's think of being better, being great, being amazing. So I still want to do this, unfortunately, but I don't want to use operators. I want to build the entire expression itself. So I want to. Actually, I do want to have. So I want to have remaining numbers, and then just keep chomping them away until I only have one remaining. Kind of like the logic we have here. So let's make a second can be made true. Can be made true better. There we go. So, we'll keep calling it incomplete. It's not gonna be this anymore. That. Well, nope, a new array of numbers. So while numbers, we have numbers. It's great. So if numbers, well, since we're here, we know there's already one there. So let's shove in an operator. And then new. So instead of shoving in an operator, let's grab the first two values. Const left, right equals numbers splice 0, 2. And yeah, I'm going to invert all of these to remove the expense of this splice, but we're in the current now. So we have left, we have right, we have operator, and then we have const new number equals forming the operator, form or or eval operator, eval operator left, op, right, and then we're going to shove it back into the thing. So that's numbers. Well, not numbers. We want new numbers. Const new numbers equals numbers. But we want this one first. So new number. Ta-da. And hey, if your new numbers has a length of 1, congratulations. You did it. Get the result, which is extracting, well, it's numbers, new number 0. Technically it is new number, but I'm maintaining the chain of custody. If it's a thing, great. Otherwise, incompletes push new numbers. Now, so you need to create eval op left number op string right number. Hey, scaly game devs, how goes it? Thanks for the raid. Hey, I appreciate it. Yeah, I am refactoring my Advent of Code Day 7 solution to be just a little better. I assume by the name you might have been developing some games. Crazy idea. Already done? Yes, I am. Yes, I am. I do go for the speed a little bit. Sometimes I'm fast, sometimes I'm not. But yep, I'm already done. Oh, fun. Nice. Yep. Already done with the core. Already walked through the challenge, walked through my raw solution, which did take a little over a minute for part 2. I am not that fast enough. I don't think I've even hit the leaderboard yet. Closest I got, I've gotten sub 1,000 on day 3. That I just completely bored yesterday's part 2, but I haven't hit it just yet. Usually there's like 1 or 2 I get lucky with. Nothing goes wrong, and I actually land up there, but I'm, I don't take it too seriously. It's mainly for the fun. Challenge somewhat is the fun. You managed to hit up the globals yourself. Yeah, sometimes they just line up, right? It's a mixture of, you see the like, does it all click in the mind? Great. You understand it perfectly. Do your fingers hit the keyboard in the right way where you make zero mistakes? Well, if both of those happen, you might just have a chance. And then you got the Vim experts that just zoom and go so fast. Ah, yes. The streaming does, yeah, I'll admit it does impact a little bit. I am not a good streamer when the time is on. I'm very much just doing it and stream of consciousing my thoughts out. So it doesn't affect it too much. But yeah, learning a new language, yeah, that's definitely not gonna get you any pluses for the times. But you gotta choose what you're going for the year usually. So yeah, that is the disadvantage of the way it's released. But there is like the personal, private leaderboards. You got some friends and stuff, and I don't know if you've heard of it, but the Everybody Codes is a Advent of Code similar thing. I think a fan made it. Yep, nice. That's always a good way of going for it. But this is like Everybody Codes. It's got like their own, like they're kind of inspired by Advent of Code, but I'm not going to click on them to not spoil them. But they have localized leaderboards, so it only starts when you open the question. So that's one thing that when I found out about this, I was like, that's a nice thing that Advent of Code like doesn't and realistically can't really do is like localized leaderboards, but this Everybody Codes thing does, and they're pretty fun. It's not Christmas themed, which is its only downside. I joke. Yeah, I suppose that is like the metagaming aspect of it. Yeah, when once they show up. Yeah, no perfect system, but assuming, your group or university, get a trustworthy group, you don't have to worry about that. But yeah, out there in the wild, wild west of the internet, can't trust no one. Yeah, among friends, it's definitely fun. Mhm. Okay. Yeah, I was just refactoring my brute force. 'Cause I went super brute force on mine. I was like, hey, let's generate effectively every permutation of the equation, which I do with a very ugly stack based recursion. And then let's evaluate the equation and see if we eventually find it. It's very inefficient. Some people have already suggested using the target divisibility and addition and cool stuff like that. I'm not gonna get that fancy, unfortunately. My brain ain't doing that on a Friday night. But what I am doing, I can see the optimization of, is instead of building an expression and then evaluating the entire thing, considering like a, a majority of the prefix is the same thing you're evaluating, I'm just going to evaluate the expression while I build the permutation, which is what can be made true better is going to be doing. And I wrote it, and I have one function left to write, which is evaluating an individual operator. So if op equals, yeah, we're just gonna do it all bad, make it work, make it right, make it pretty. Nice, yeah. I imagine, yeah, but well, then I know this is gonna work then. Yeah. My concerns with part two was like they would have us do something completely different. So that's always the risk of I can do it the right way, but then the right way might not be useful for part two. But yeah, hindsight 2020, obviously that's the better way of doing it. Yeah, I've heard the glorious greatness that functional languages can give. Yeah, got a few people at work who praise them like Elixir and stuff, but eh, I've yet to take the plunge. TypeScript is good enough for me, and I can do functional stuff if I want to, but I have worked, I believe, Elm a while ago, and I've seen the light at the end of that functional tunnel if I were to get into it. Most efficient operational evaluator in the universe. Left, right. Good enough. Let's see if I can get this working. I haven't actually ran any of this, so we're about to find out. It's alive! Oh, yeah, this, honestly, yeah, Advent of Code, very classically a great place to try out new languages, and a relatively good thing to try out with a functional, too, considering how input output oriented they are. Well, no side effects, none of that. Oh, yeah. I ain't gonna give them the money. It's they just leave activate Windows there. Suppose I could, restart the computer every now and then to get that to go away, but I do not mind it. Okay, I think that optimization did the trick. Now, did it do it enough to make number generate fast? Well, that looks good. This one took like 20 seconds to generate last time. My computer doesn't like this one. Hey! It takes less than 2 minutes. That's a success in my book. Considering the last time I didn't think it'd complete, and 2 minutes later, we done. So, now that we have this proof of concept proved out, let's give it the last layer of polish. So, we go through them all, we split them. So we have parsing smushed in with my logic. I don't like doing that. Um, let's get this parsing. Do I just inline eval and run functions inside my VS Code script file? Oh, so this is an extension called Quokka. It's a VS Code extension that you can run. I mean, it's not just VS Code, it's a TypeScript, JavaScript extension that you can run that takes your code and just reruns it every change you make, and also allows you to do some pretty good debug logging stuff. So if I were to console that out, um, I'm trying to think of an example. I can't right now. If I just put a line here, it effectively console logs expression statements that are just expression statements. If you do a console log, it'll show those kind of just inline in my editor. Oh yeah, this is amazing. Now, I believe there are free versions of it, like, and I've used the free version for entirety up until like last month. And I think with the paid version, you can do like bigger projects with like multiple modules and stuff. But the free version will get you all this everywhere you need to be basically. And they have an equivalent So they have two things. One's Wallaby and one's Quokka. So Quokka is they both do the same thing. Let me show you actually. And yeah, it's relatively good. Gives you this, gives you this, gives you timeline debugging with time traveling, a whole bunch of other stuff. I don't use it all, to be honest. Just the quick responsiveness is good for me, and it's really good for teaching new people too, because they can literally see instead of console log, look in a terminal, what line was that, what line was the console log. But it's like Quack is like your scratchpad variant of it just runs the code in your file, kind of REPL style. Wallaby is the next level up where it integrates with your testing framework of choice and it does just like the magic things, but integrated with your testing framework. So this is where like the value actually is. And it does profiling and other cool stuff. Oh, hey, hey, hey. Thanks for coming on with the raid, Stu Squared. Hope y'all had a pleasure over there. Were you doing anything fun? Probably having a code, but you never know. Either way, hope it was a good time. Having code day 7. Hey, I am just putting the last bit of polish on my refactor of Advent of Code Day 7 right now. I had it very brute forcey originally. To the point it took 2 minutes to generate my part 2, unfortunately, but then I came back with a little bit more efficient brute force. Oh, that. Yeah, that's always the painful one there, Stu. Yeah, it's either, at least for me, whenever I'm messing up on this, it's like 45% of the chance I'm just completely missing something. Like, I didn't read one of these words that weren't bolded. The other 45% of the chance, my fingers are hitting the keyboard wrong. I am just goofing in every possible way. Last 10% is I don't know the very cool, efficient algorithm that I need to know. But yeah, debugging a function that was already correct. That's my second 45%. I'm just straight up goofing into a hash map instead of a list of tuples. Oh, lost the duplicates. Yeah, that would do it. Mm. Yeah, it's definitely one of the goofs I've made in the past of like, okay, I'm doing this thing. Then it's like, well, it's got to be the rest of the complicated code that's broken, not the simple code that I'm making assumptions on its behavior. And yep, it's always the simplest of assumptions. You gotta validate them all, which is why I do like Quokka or just rapidly console logging. Accidentally parsed. Oh, yeah, I made the literal exact same assumption, Scally. I assumed my X misses could be plus misses, and it was just calculating too high, and I was like, what's wrong? And I was like, wait, X miss needs to be in the shape of an X? That's, how could I miss that? mm. Oh, wow. I wonder if that's a coincidental or purposeful pattern there, Stu. Guess we'll never know. Let me try and spell this word better. Nah, let's leave it there. Um, yeah. The last bit I'm doing here is just making this a little cleaner. Because before I was generating all permutations of the expression, then just evaluating them. And now I'm generating the expression permutation, the permutation expressions while evaluating them. So instead of evaluating the same prefix 15 times, I evaluate it once and then just take the number, go forward. Yeah, I think that might have a coincidence there. I'm seeing some correlation there. Happy birthday, by the way. Always a fun time. Yeah. Okay, let me think what this function was doing. Yeah, the thing I didn't like the input parsing being smushed together with the processing. So I'm just gonna do that better. What do we call these? Equations. Local time for me is midnight. I know it says 1 a.m. My computer's clock is off. It's still in the wrong time zone. But it is midnight for me. Map line. Oh, we're not jumping anywhere. Yeah, definitely. I do not envy those who have this in literally impossible, like you said, the 6 a.m. Time zones. It's like at least that one's somewhat like some are early morning people. Like I'm an early morning person on some days. I can get up at 5, but the ones, the twos, the threes, the 4 a.m.s. Yeah, you really gotta be dedicated if you're going for that. Let's see what I want to call these. Test value. They call it a test value. I hate calling it that. And then what are these? The remaining numbers. Numbers. Good enough. Turn. Oops. Test value and numbers. There we go. Oh, I was wondering where all those symbols came from. Now we can go through my equations for test value numbers of equations. Bop, bop, bop. Whoops. I like it. And you know what? Let's go full functional while we're here. Of course, yeah, yeah. Go ahead and get some sleep. Again, appreciate you coming on by. Yeah, I will. Maybe next tomorrow I'll be the one raiding you. So some we have test value numbers. I feel like I've done this wrong, but I'm gonna go for it. I'm gonna ignore TypeScript and assume I am the correct one and TypeScript is wrong. Yes, I was correct. The TypeScript was wrong. Or it was right. I didn't take enough time to read it. So we have this, we add to the sum, we do this. I want to go a little further. Let's go with a filter first. Yes, we are being very inefficient, but we're being a bit more pure. Oh, value, numbers, then this reduction. Why do you need 3 values? Oh, you need your operators. Okay, and then this reduction can be simply generating our sum. So A, B, in my parentheses, A plus B Operator cannot be applied to... Oh, that's right. I just have a bunch of test values. I need to map them. I'll do the mapping and the reduction. I think that's too many parentheses. No, stop importing whatever it is you're trying to import. Okay, when we have our test value. Okay, so let me make this a little bit more readable. So we have our parsing, which takes our data, splits it, parses it into the test value in numbers. We filter out the ones that can be made true. Drop the better now that that is our current state. And then we reduce by adding up all the test values. I like that a little better. We have this ugly thing here, and then we have this ugly operator evaluator here. So, so I got three ideas. Make this prettier, make this prettier. Replace operators with an array of functions versus an array of strings, because effectively we are performing a custom function per operator. Just two of them happen to be built in using the symbols we're using. So I'm going to go for that, because that's going to allow me to push things off. So my operators also going to make this acceptable as REST arguments. There we go. There we go. That doesn't change anything yet, but that's what I want. So operator here is just left number, right number, left plus right. Hey, X metric, yeah, I've decided to come on back for advent of code. I mean, that's what I did last year. So at least I have somewhat consistency. It's like, hey, at least I'm doing it once a year. But yeah, back for advent of code. Gonna make no promises outside of December, but at least I got this going somewhat consistently. Hope life has been going, treating you well. Um, I don't like these being inline. I'm gonna make these functions. Ah, sorry to hear that, metrics. Yeah, it. Eating is boring, huh? It's a take I haven't heard yet. Ah, the motions of it. Yeah, I see what you mean. Yeah, it can be tough for sure. Not giving you the magic solution because I don't know the magic solution of that. That's the big, unfortunately, relatively common challenge. The little things, sometimes they are enough to get you to the next week or get you to the next day. Of course, eventually one runs out of little things. You gotta have more persistent, longer term goals, but those are, of course, the harder ones to come by. But I appreciate you coming on by. I'll hopefully that will at least be something. Yeah. So this operator thing. Yeah, I'm placing these with a bunch of functions that will just take left and right and do stuff with them, returning a number. Gave it a custom type, and now, well, I have to do it for this thing here. Add, multiply, concatenate. What's concatenate I'm looking for? Huel? Never heard of it in my life, Stu. A potion. I believe you completely. So I have to spell the word concatenate first. Ooh, nice metrics. Yeah. I'm trying to remember what day 6 is. I'm being a complete goldfish. Oh yeah, this is yeah, that's gonna be a real fun one to visualize there. Go for it. Yeah, I've been keeping a track of a couple of ones I like to visualize. Don't think I'm really gonna go for it too much. Life is a little busy, so I'm not committing to a visualization every day and then abandoning that at half of them. Just gonna go through it. And then convert back to number. Then I spell it correctly. And it's broken. Why is it broken? Ah, this function doesn't support my fancy operators. Hey, fancy operators. So new number is op. And you just call it with left and right. Why is this not? Oh, because this is a string array instead of an operator array. Boom. Let's rename that to the singular operator. There we go. Okay, this is working beautifully. Probably a little slower because function calls are not a free operation, but I like it. It's cleaner. So now we have this thing. This is our last blob of ugly. What we want to do here, I personally don't mind this effectively stack variant of recursion, but I have been, told many of times this is not the easiest to follow. So there's converting it to a true recursive function, and then just making this a little cleaner. Let's clean this up and then look to converting it. And there's reversing it too, because I'm doing this splice, which is expensive just to reconstruct and build. So if I splice, it'll be right left. Well, if I reverse it, rather, it'll be right left. So let's go for that. That's an easy win. An easy testable win. Splice -2. I think that'll work. And then it'll just be right left. No, 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 no. It's not that way. That's the wrong way. Because I'm putting it back in the front. Yeah, it needs to go on the back. No? Yes. 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 Loving it. Okay, so that just makes that more efficient because you're not, if you remove them from the beginning, it has to recalculate all the indexes. It's more expensive than removing it from the end. Now, well, we're still creating a whole new array. It ain't pretty. We can do a quick check on this to check if all the numbers doesn't have a length instead of just always creating new numbers. So if you ain't got no one left, then do your thing. Otherwise, well, then you can push your new numbers onto the next portion. And we can now directly access new number, which is just checking. Love it, love it, love it. Let's try and invert. Whoop. If there are any remaining, do your thing and keep. Don't concatenate, continue. Otherwise, try and do this thing. Okay, I am liking it so far. Let's go for the recursion. So, function recur, and it's basically remaining numbers. And then what do we want to do? We want to say, so it depends on where I want to move. So right now I'm having my base case before we go to the next one. We'll replicate that in here. You still want to do right left is remaining splice 2. Do all this code. Just take all the code. So this is all perfectly great code. But instead of incomplete to push, it's going to be if recursion call true return. If recur with the new numbers array, return true. And then, and we don't want that no more. I feel like I'm missing something here. I guess I return false. Clear the signature up. Feels weird, feels gross, feels like I'm missing something. Let's see if we can do this. Return, recur. I think it's numbers. Well, it's a new copy of numbers that is reversed. Maximum call stack. Oh no. See, this is why I sometimes avoid this as the first thing. I get this problem. So it's possible I've done an infinite. It's interesting we're getting it on this one. Make it tail recursion, no stack issue. Yeah. I forget how that works. I mean, I remember it when I first learned it. Oh, I'm doing the condition here instead of there. Okay, yep. Didn't you do brute force? Unfortunately, it was a Friday. Well, it was the night of a Friday, so it was the morning of a Friday, and it was a busy Thursday night, packed Friday, so I didn't end up doing it. Was gonna do it today, but today was still a packed Friday. Probably gonna do the part 2 of day 6 tomorrow. Yeah, life happens. It ain't going nowhere. I'll get to it when I get to it. I did have some thoughts about it, and like the way I was doing it, it was brute force, but it was the most inefficient brute force. Like, I have a find that calls JSON stringify to look for caches, and like just saying the words out loud, it's like that was the least efficient way how I've done it. Yeah. I mean, I'll show you with the badness right now, and I'm not gonna go for it now because I'm still doing this. But the badness, no, not here. Here it is. So I'm using visited to track things I've been to, and this is just an array, and I'm using JSON stringify to detect if I've been somewhere before, instead of, making this a set and doing a dot has. No, my brain didn't think of that in the moment. It thought this was efficient. So honestly, I think if I just swap this and maybe I think that's the main thing that's making it so long, and then maybe just I will be able to brute force it and time will help me. Yeah, of course I didn't think of that in the moment. Okay. Tails. If remaining dot length equal 1, return remaining a 0. Triple equals the target. I think that's what I want to do. Drop the continue. What have I done wrong? Uh-huh. Yep. I had the spirit of my idea was that metrics. I just did it in the least efficient way possible. Operators. Why no? Only check locations the guard have traversed from the last position of the starting. Yeah, I mean, not to get into it, but like, I tried to do a really efficient thing where I did pathing lines. Let me actually see if my TL draw is still here. Here it is. So basically, like, I drew like, hey, these are the vectors of lines that you have crossed. When you cross one again, that's a position you can infinite loop. And I thought that worked, but it didn't generate all of the results on the real one. It worked on the test, but it failed on the real. So, like, I believe this is a good theory, but it's missing something. Only if you hit it from the same direction. Yeah, like I'm only considering this because it's a right 90 degree. Like you don't consider all pathing lines. And then like this one, you wouldn't consider this yellow one as something to put an obstacle because it's not a right, it's a left. But I don't know. It was a good idea. I just went too far too quickly. How do I tell? Um, the last operation. Let's see if we can get some help from make this use tail recursion. AI. It's gonna take our jobs, everyone. Look at this. It's gonna take our jobs. I'm feeling pretty safe right now. Just butchered my code. What Yeah, this is also why I don't do recursion, because apparently I don't know how to tail endify that. Good enough for me. I appreciate the lurk metrics. So let's just call this processing. So we get that type out of the way. Eat up all the stack memory. We live with our life. It's fine. We can move this up. I'm fine with it here, honestly. And let's drop this to an else if. Just like that. Yeah, I'm liking this. Okay, so let's go through it one last time. So, what we want to do is. Hey, I appreciate it, Stu. Yeah. Fracture's looking good, and I'm looking forward to day 8 and finishing my day 6 part 2 tomorrow. So, here is the solution. So, for each line, we split by the new line, we go over the line. So, this first little bit is just parsing each line into the test value and the numbers. We split by a colon space to give us left and right values, where left is whatever's left of the colon, and right is whatever's after the colon. So it's a string of space delimited numbers. We turn the left into test value using the old unary plus operator to numberify it. The right one we split into an array of strings separated by spaces and map each of those to a number using the number constructor. We then return both of those and an object using the shorthand syntax. Keys are these. Then, for each of those lines, we filter to only keep the ones that can be made true. And I'll go into that function soon. For every line that can be true, we add up all of the test values, which is what this reduce is. It takes, and I'll give this a good name, it takes the sum, which starts off as 0, and adds test value. Can be made true. This is where all the fun happens. We start off with effectively our first call to our iteration-based recursive processing, which is taking our numbers and reversing it. We do this solely to give us some improvements when pulling things out of it. We then take the one, just pop off the latest one that was added. We get the right and left number by getting the last two from numbers. So if I show this off, pre and post, so we have 1910, which turns into empty. This is very useless. Let's look at the next one. 274018 turns into 27. Because 40 and 18 are right here. 40. Well, if I've been saying 18, I meant to say 81. I don't know why I read it backwards. But we have those numbers. We pull off the last two, which is more efficient than pulling off the first two. We destructure them into right and left because despite them being left and right, they are right and left because we have reversed it. We then go through every operator function we have. We generate a new number, and I'll go into the operator functions in a moment. And then if there are any remaining numbers that need operating on, well, we say we have another thing to process. We push it a new array of all of the numbers that still need processing and this new one. Otherwise, there's the possibility that that new number you just generated, so there are no more numbers to look at. So there is one number, the new number, which is the final number in this case. It may be equal to the target. If it's equal to the target, well, stop the presses. We found what we're looking for. We are returning true. And if we unfortunately go through all of the permutations of expressions and we don't find it, well, then we are very sad and we return false. We were not able to make the target. Now, the operator functions is a little bit of magic I added for readability. The solve method can receive a variable number of functions that take in two numbers and return another number. These are the operator functions. They're relatively straightforward. Add takes in two operands, it adds them together. Multiply takes in two operands, it multiplies them together. Concatenate takes in two operands, it turns into strings, smushes their digits, and then returns that number that is made up of those digits. The only difference between 1 and 2 is which operators are used. 1 uses add and multiply, 2 uses add, multiply, and concatenate. So when we have these operators here, these are our operator functions we iterate over, which is how we get our new number spat out to us. That's it, honestly. As is tradition, it's a little cleaner when we refactor it. And that I personally believe is as far as I will take this. I know part one has that optimization with divisibility and some short circuiting branches, but I have no vision of how that would work with part two, so I won't even be attempting it. So I will optimize. There's the message I was looking for. Optimize day 7. I will commit this and call that stream. Let me go on the prowl. Look for some other advent of coders who are streaming. Any suggestions? Feel free to suggest them now before I find someone myself. But it has been a pleasure. Where did the tags go? Okay, don't know how to do that. Fine, I'll just search. Their search can't be too horrible. There's the tag. Okay. Okay, looks like it's not too many. Gained interest. They're doing something advent of Cody. Let me go check them out real quick. Yep, they appear to be doing advent of code, so I'm gonna send y'all over there. And yeah, with that, it's always a pleasure. I will be here tomorrow night. Toodaloo.